So this exercise related to simple harmonic motion. And we'll do question 6. As I mentioned in this topic, a simple harmonic motion, a short derivation as we did in the last week. The derivations related to the topic are there. A car suspension system can be thought of a mass spring system. So we can consider a car suspension system as a mass spring system. The natural frequency of the system is determined by the force constant of suspension K and the total mass of a system M. A car is set into a vertical oscillation by applying momentary downward force. Show that the frequency of oscillation is given by this formula. So in the question they mentioned, we can consider a car spring system as a car suspension system as a mass spring system. It means a mass, when a mass is attached to a spring, we can consider that same as the car suspension system. Working principle is the same. So we have to show that the frequency is given by a formula F equals 1 over 2 pi K divided by M. So how to do this? First thing, where F is a frequency, not the force. First, we have the formula F equals ma. Force equals mass multiplied by acceleration. Like what force we applied on the spring, and they mentioned it is subjected to a downward force. So you can consider here, like there's a spring, and that spring is subjected to a downward force. F is there. So according to Newton's second law, we have the formula F equals ma. When we compress the spring will apply force in opposite direction, and the force exerted by the spring, that is given by a formula F is equals to kx. That is, if you remember the Hooke's law, according to that, force is directly proportional to extension, or F equals kx. But the force which we applied is F equals ma, but the force which the spring apply will be in opposite direction, that is F equals kx. So how we represent that the two forces have a different direction? In physics, we use the different sign. So if we say this force is F is, and what force we applied, the same amount of the force the spring will apply. So we can say the two forces will balance. If the force we applied is F equals ma, force applied by the spring is F equals kx. So the two forces will be balanced, but the only difference, one of the force will be negative. Why? Because if we apply a downward force, the spring will apply an upward force, which is in opposite direction. So how we represent the two forces are in opposite direction? By showing a negative sign. So we have the formula F is equals to ma, and we have F is equals to kx. So we can say ma equals to kx. Or we can also say A equals to minus k divided by m into x. Now, what is acceleration? Acceleration in terms of like when we relate the circular motion with a simple harmonic motion, the acceleration in a simple harmonic motion is given by a formula minus omega square x. This is the acceleration of any system which perform a simple harmonic motion. Its acceleration is omega square x, where omega is the angular frequency and x is a displacement. So we can compare, we can say this is equation A, this one is equation B. So we can compare equation A with equation B. So when we compare, like I can say minus omega square equals minus k over m. Why I'm comparing this manner? Because A is equals to A, x equals to x. So we can say omega minus omega square is equals to minus k over x. Negative will cancel with negative. So we can say omega square is k over m. And what is omega? Omega is an angular frequency. We have the formula omega equals 2 pi f. So in place of omega, I can write 2 pi f square, because it's omega square, is equals to k over m. When we simplify, this will be 4 pi square f square k over m. If I need frequency, so I can say f square is equals to k over m and 4 pi square. If I need only frequency, what I will do, I'll take a square root. When we take a root, so f is equals to 4 pi square, it will become 1 over 2 pi under root k divided by m. So the frequency of a system which is performing a simple harmonic motion, or frequency of a system, a mass spring system, is given by a formula f equals 1 over 2 pi under root k divided by m. So I did this derivation in the last week explanation, that if you have the time, you can also derive a formula for the time period. You can also derive a formula for the frequency. So this is the thing which you have to learn, especially the derivation for the frequency or the time period for mass spring system or a simple pendulum. Is it clear, this derivation? Any doubt in this? The next question, the car is displaced through a vertical distance of 27.5 meter, 27.5 millimeter, when the mass is 85 kilogram, sit in the car. Show that the K is about 30 kilo Newton per meter. So how to work out this? You have the simple formula F is equals to Kx. Like the force which is applied is equals to Kx. The force which, whenever, like example, they mention a car spring system is there, a person of mass, a man of mass 85 kilogram is sitting on it. So if the mass of a person is 85, what will be the weight of the person? It will be 85 times 9.81. So the force which is applied here, that is 85 times 9.81. K we don't know. And the car is displaced through vertical distance. So how much is our displacement or the compression is there? That is 27.5 millimeter. We divide by 1000. So 27.5 into 10 to the power 3. So if we need K, this will go there in division. So 85 times 9.81 divided by 27.5 into 10 to the power minus 3. This will give us the value for K, which is 3 exponent 4, or which is equals to 30 kilonewton as well, Newton per meter. Calculate the natural frequency of a car with a man sitting. The mass of the car is 1130. How to work out the natural frequency? You have the equation here. They mentioned in the beginning that this formula is used to calculate the natural frequency. So you have to use this formula F equals 1 over 2 pi K divided by M. So the same formula F equals 1 over 2 pi K divided by M. So we already calculated the value for K. So it will be 2 pi. K we calculated 3 into 10 to the power 4. What about M? The man, because the man is inside the car. So what will the total mass? The total mass will be equals to sum of the car plus the man. So the mass of a car is 1130 and the mass of the man is 85. So when we simplify, we get 0.79 hertz. That is the frequency at which the car will vibrate, the natural frequency. In part B1, car suspension systems are example of damped system. What is the meaning of damped system? Damped system means like we remove the energy from the system. We call them as a damped system. State what is meant by damping and explain why this is desirable for a car suspension system. Like what is the meaning of damping and why we want the system to be damped. So static questions, your work must be clear and it should be organized whenever a static question is there. So what is a damping? What is the meaning of a damping? The damping means we remove the energy from the system So when we remove the energy from the system, what we call that? We call that as a damping. And why it is desirable, like why we want the system to be damped, especially in a car suspension? Because what will happen? The damping will reduce the amplitude of the vibration. And when it will reduce the amplitude of vibration, so the car will return back, the oscillation will die away, or it will prevent the energy transfer to the car body. Otherwise, the car body will continue to vibrate. So damping means removing energy from the system. And why it is desirable? Because it reduces the amplitude. And what is the advantage of reducing the amplitude? It will prevent multiple oscillations. And make the trip smooth. The next part, the graph shows a displacement. We have to sketch a velocity time graph. How to do this question? As I explained this in the last session, that if you have, first you identify what is the displacement time graph. So this displacement time graph is a sine. So if the displacement time graph is a sine, what is the derivative of a sine? The derivative of a sine is cosine. So we have to draw a cosine graph. And what is cosine graph? It will start with the maximum. It will start with the maximum, then it will reduce. But you have to draw in the same cycle, like when the displacement is maximum 0, then maximum, then 0, then maximum. So this should be a cosine graph. How the marks are distributed? One, when you mention like cosine graph is there, the shape should be cosine, and the amplitude. But and it is a damping is there. Another thing, because this is a damping. So we have to make a cosine graph, but we should also show a damping happen. So how we represent a damping occur? We have to reduce the amplitude of vibration every cycle. So first it is 0, maximum 0, then maximum, then 0, then maximum 0, and so on. So the amplitude of a vibration should decrease. Is it clear, this question?